of us as researchers fail. What we do, data आ गया, क्या करेंगे? We'll go to the statistician or go somewhere, a person who knows little bit of using Excel, this, that, and all the softwares. We go and give the data to him and say, this was my research question. Please do some analysis and give me answer. Please, you have a question? Yeah, wait. Yeah. 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 Yes. This is sample design. Yeah. Fifth one is sample design. Sixth one is data collection. And seventh one is data analysis. सप्त ऋषियों में एक ऋषि है. Right. You had a question. That's what I'm saying. Yeah, wonderful question. She says that, the first step is the statement of the problem, and then you're going into research, right? Literature review. Now, statement of the problem is a statement. It's not your title. Statement of the problem is the problem that you have identified. I wanted to work on tigers in India. When I do literature review, I found out that there are 457 Ph.D. degrees, PhD theses on tigers in India. Do you think that I would do research on tigers in India? No. And during the literature review, I found out that there are only 2 people or 2 theses or 2 research papers that are available on breeding biology of tigers in India. Then I will say I will work on this because there is no data or no information, right? So statement is a general question to begin with, right? Yeah. No, not at all. Please go ahead. Yes. Yes. How do you say this is the first person, you are the first person? You have to do some review. You have to do some research. No, I have to have that nobody has done. So even for that also you have to do, right? Yeah, you have to do a research. Yes. हाँ, ऐसा नहीं है कि मैं ही महान हूँ. No. Just what you have to understand is when people say this thing that this is the first time that I am doing, then we ask, have you done the literature review properly? If at all, then for that also you need to have. I have studied 100 published material on this particular thing, and nobody has worked on this. That's the reason why I am the first. Yes, it is necessary. I have a question. Yeah. You would be surprised when sometimes scholars are sitting with us on an average 7.5 years average in my lab. 7.5 years. I'm telling you, these are because of 2 reasons. One is, if people like us, if you don't get data, we'll kick you again and again, go get the data. Because we are not going to, just accept no data and kuch bhi likh doge, pass ho, degree de denge. Not that. Second thing is, sometimes what happens, nowadays it is not there. Sometimes what happens is, student joins, after 1 year or 2 years, he gets a 5-year fellowship. So he continues, sir, paisa aega, sir, chhod dijiye, sir, and all such kind of things. My son is pursuing his PhD in University of Reading in UK. 3 years. They will kick him out. 3 years. 3 साल के अंदर में 3 पेपर पब्लिश कीजिए, कंपाइल कीजिएगा, PhD डिफेंस कीजिएगा, बाहर निकलिएगा डिग्री लेकर. In here also we have that 4 years for your full time and 5 years for your part time. That's there, but sometimes things happen in such a manner. I had a fellowship, 5-year fellowship. I completed my work in 3 years. As I told you, first 6 months for understanding what I am doing, and last 6 months I kept it for writing and all those things. But simultaneously I started writing all my chapters in the second year onwards, because my objectives were already realized. So I started writing and everything went on. In 4th year I submitted my thesis. 5th year fellowship still was coming in, and I was enjoying doing more work. PDF work I was doing as a doctoral fellow. And 5th year, it took almost 1 year for my PhD reports to come in. And December 99, I submitted my thesis. December 2000, I got my award. 1 year I enjoyed the fellowship. But I was working, I was publishing papers, right? That's what it is. It is like, that's the commitment that as a researcher you have to have in your heart. Okay, aa raha hai na paisa, main sab my guide, sir, Tata, I've submitted. When the reports come, you call me, I'll come and present. Your commitment speaks, right? So that's how it works out. Right. Let's get back to, yeah, please. See, one thing is, I'll tell you one thing. If you have done when you're writing a synopsis and you have done a literature review, which is say 50% of the literature review that you have already done, doing your literature review in the first 6 months is 50% done, right? It would help you rather than how. If you do 100% of the literature review also, you have that work which you are going to do now in next 2-3 days, 4 days, 10 days is not going to go waste, because that is going to give you clarity that you are on the right step, right? You are on the right path. You have taken the right decision to ask the right question, right? And my objective framings are correct because nobody has worked on these things. You're getting my point? So it will help you. Now you might be thinking, kya karenge now? But at least you do some kind of preliminary research, literature review to find out what exactly has been done in those. For example, I get so many proposals for working on so many different things. And when we look at the proposal, we already say, yeah, there are three theses in the same department, and there are at least a dozen papers, research papers, that have been already published in public domain. It is available. How am I going to accept that proposal, right? So that's the reason why, to be on safer side, you have to do that work, right? No. I will tell you one thing. How narrow or how broad should not be in our head now. What should be there is how novel is my question. What new am I giving to the society? Is my research for next 4 years or 5 years going to add to the existing knowledge? Novelty is more important than focus or breadth, right? You got the point? Okay. Now, when we think about the data analysis, this is where it's the most daunting task that you would be having, because most of us, when we are doing research, we collect the data. And when we are collecting the data, there is some purpose of collecting the data. And when we are not utilizing the proper tools, statistical tools, or we do not have proper understanding about what tools we need to use and all such kind of thing, right from the beginning, as I told you, we would be on the mercy of so-called statisticians. They would charge you something. They would give you results. You will go and say, this was my objective, and whatever he understood, he will give you. Garbage in, garbage out, right? And you bring those things, you are happy, chalo koi to kuch karke de diya, and come and start presenting in front of an audience and a committee. And in that committee, if there's a gentleman or lady who knows little bit of statistics, They will ask you simple questions and you would not be able to answer because that part of your research journey you did not walk, right? Somebody else walked. So that is a wrong way. I tell that, if you are not interested in statistics, don't do research. If you are interested in, doing research and you don't know how to do statistics and all those things, go sit with the statistician, tell him the questions, find out the answers. Sit along with him or her to get the results. See what is being done. Tell statistician, if you don't tell, he will take treatments as groups and groups as treatments. If one mistake and you are coming over here and showing this thing, it becomes a novel science, but it's not correct science, right? It's not correct science. So you have to have thorough knowledge about these things. You have to learn. As a researcher, this is one of the skills that you have to learn. You have to have basics, and you don't have to invest a lot in statistical tools or when I say statistical tools, the softwares. You need to have idea about all these statistics. But if you think that I need to learn SPSS, I need to learn PASW, I need to learn PAS, I need to learn this, that, and all such kind of things. No, if you know how to use Microsoft Excel, lots of statistical analysis can be done right over there in Microsoft Excel. But only thing that you have to learn is how to tabulate, how to collect the data. The first things that I teach in research methodology, when we are teaching them about how to do statistical analysis, basic statistical analysis using your Microsoft Excel, we teach that whenever you are writing anything, documenting, collecting any data, make a proper table. You should know what are the columns. You should know what are the rows. What data is going where. If you don't know those things, you get confused right from the beginning, then it becomes difficult. So many a times you need to be, paying more attention towards this particular part, because this particular part makes your research more interesting. There are students who come to us and says that by inducing this particular drug, we have seen that this behavior has increased. Then I ask, so what? If you give me lots of water, my behavior also change. You add something in that water, it will change more. So what? Tell me what exactly you wanted to ask and what exactly you are showing to me. Then I say, sir, kahan galat ho gaya? I said, okay, you compare with control. There is a person to whom you have given water. There is a other person to whom you have given water with the dosage drug, right? Then you compare the behavior. So you are seeing the point where we are going to. So these things become very, very important when we are talking about data analysis. So when we do these things, we do wonderful research, but we are not able to do the data analysis, wonderful data analysis, and show how statistically significant your results are, right? It's not just that, I have seen this has increased, this has gone down. बहुत सारे PhD वाइवा वाले में बैठा हूँ, चाहे वो साइंस में हो या नॉन साइंसेस में हो, they are so eloquent in presenting their research results, but at the end of the day I have a big smile within my heart and say कि भैया कहीं नहीं जाओगे आप, accepting the degree, right? The degree in front of you and a piece of paper in your home, you are not going to go anywhere because you have lost the whole essence of what this particular step is going to give you or where it can take you to. And finally, you have to report your PhD thesis or your research papers that you would be publishing, and all those things would be the final part of your research design. So research design are those 8 steps. If you are not understanding these things, it would be difficult for you to prepare your synopsis. It is very, very important that you should understand. And that's the reason why I've told you, if we are teaching research methodology, in this research methodology, you might be thinking, sir, फिर zoology department से बहुत लोग अच्छे researcher बन जाना चाहिए था, right? You might be thinking like that, but unfortunately, it all depends upon the taker, right? I'm packaging it and I'm giving it to you. It's up to you to use this format to move forward, or else, yeah, bless you. So now the biggest question is how, which type of statistical test I should. When I go to class and say, today I'm going to teach you this, sir, the initial reactions when I used to say that, we have to do biostatistics, my students used to just bunk classes. 2-3 से शुरू करता हूँ. That student बोलते हैं जाके कि सर ये पढ़ा रहे हैं. My class gets filled up in the subsequent classes because there's something new that is coming up. And when we think about these things, then we start thinking about, yes, these were the questions. This is what I have asked. This is the data, the quantitative data, qualitative data, categorical data, ordinal data, what all type of data that you have collected. Don't worry, it's all there. You have to remember that what type of data you are having, and then you have to go forward doing the tests, applying the tests, and trying to see what is going to happen. Now, the biggest question now here, when you are at the stage and starting to wonder, what am I going to report? Mostly we say that your reporting should be whatever data you are collecting, right? Quantitative, qualitative, and all such kind of things. You have to report the measures of central tendencies and measures of dispersion. So when we talk about this, if you are working with quantitative data, you have to give us mean plus or minus standard deviation, right? If you are talking about the qualitative data, you have to give me medians, modes, and the range. So if you are aware of these basic things, it becomes easier for me to start thinking that, okay, if I have to report my data, that if in my class, how many of you like Cadbury chocolate and how many of you don't like Cadbury chocolate? If I just say that 50 of them like and 20 of them don't like, it tells me that that comes from a single replicate, right? Only one single replicate I have taken and I have done this reporting. If I say that 50.2 plus or minus 3 like Cadbury, 20.1 plus or minus 7 don't like Cadbury. So I have a range that tells me that there is some kind of replication. The researcher has done repeated tests. So that becomes very, very important. If you come and report to me one value, I know that you are a lazy researcher. If you come and give me n equals 12, that is, I have made replicates of 12, 50 questionnaires I have submitted, I have collected information from, or 3 times or 10 times I have replicated this experiment. If you are in science, then that tells me that you have put more effort to get more of information, because all the data would be following the normal distribution pattern. And that is what, if you are looking at only one thing, if 20 of you are saying in this classroom Cadbury is not good, I mean Cadbury is not good, right? If I pick up one student and ask Cadbury is good, the answer that one student is not the exact what you say portrayal of my whole population, right? The more the merrier. That's what it is. So that's the reason why we say that you have to do replicates and all such kind of things. And all, when you are doing all such kind of things, you would be starting to ask many different questions. Like this is very small cartoon as such, and you can see, depending upon the type of data, you can either get into whether the data is continuous or it is discrete or categorical. If it is continuous, you ask the question, type of question. If it is discrete and categorical, you are doing chi-square test, very simple test, chi-square test, because chi-square takes into assumption of what you have observed and what you were expecting, because there is some kind of ratios that are you were expecting, and you would be doing chi-square test. If at all your data is continuous, you would be asking a question, am I trying to find out the relationship between the variables that I have studied, or am I finding the differences between the variables that I am studying, right? If I am studying the relationship, then you would be asking, do you have a true independent variable? If you have, then you go to do the regression analysis. If you don't have independent variable, then you would be doing correlation analysis. When you see that your data is parametric, right? You would be learning about, you just have to remember these terminologies. If your data follows the normal distribution, you do the Pearson's R. Yes, I'm stopping here, please. Regression, relationship, if you have the independent, yes, then you will get into regression. If it is no, you are going to get into correlation. And your data is following normal distribution, then you are going to do Pearson's R. If your data is non-parametric, not following the normal distribution, then you are going to do Spearman's rank correlation. Yes, Spearman's rank correlation for non-parametric data. Now, when we are looking at differences between what is the biggest question. Now, differences between the means. If I am looking at differences between the means, then I would be starting to see how many groups I am studying. If I am doing 2 groups, then I will do students t-test. If my data is parametric. If I have more than 2 groups, then I would be doing ANOVA, analysis of variance, right? If your project tells us, your questions tells us that I would have a control group and I would have a treatment 1 group and a treatment 2 group, then comparing all the 3, I would do analysis of variance, right? So you start thinking about, if you have 2 groups, you go, if it is parametric, then you have to do the students unpaired t-test and paired t-test and all such kind of things. That's what I said, t-test. And if it is the more than 2 groups, then you would be doing analysis of variance. Depending upon the parametric and non-parametric data, you would be either doing the ANOVA or you will be doing Pascal-Wallis test and all such kind of things. So all those things are not needed right now, but you would have clear-cut idea that, okay, this is how the flow happens. This is why it becomes very important for us to have at least this particular thing. You can just write down flow chart for selecting commonly used statistical tests. Google it, you will get this thing, and just keep it with you and use it when you are going to do the real research. But these things have to be understood and on a very basic level, and then you have to incorporate this into your proposal, synopsis that you are writing. So you have parametric tests, you have non-parametric tests, and then what we have to remember, the parametric tests would be like parametric data or parametric tests would be having normal distribution. And here, when we are having parametric tests, we do regression tests, comparison tests, correlation tests, etc., etc. In case of non-parametric tests, we do the Z, chi-square value. First chi-square test we do. Now that is from where we begin, and then later, if at all we are dealing with multiple data and all such kind of things, we would be doing Pascal-Wallis tests and all other tests that are available, right? So when we are talking about parametrical tests, then we would be talking about regression. Regression is something that you have been told. But Aditya was talking about regression and all such kind of things. But basically, what exactly is regression doing? It is looking at the relationship and trying to give a prediction. Regression and correlation are taught together, right? Correlation is something that talks about the relationship later in the slide, but you will learn about it. But basically, to make you understand what regression, how it differs from correlation, it is the relationship between 2 variables. Most of the time 2 variables, and you might also have multivariable regression and multivariable correlation also can be done. Multivariate, we call it as multivariate analysis. But correlation looks at the relationship of the 2 variables. How are they positively related to each other or negatively related to each other, or there is no relationship. When they are positively related to each other, you increase one variable, the other variable also increases, right? Negative, increase one, the other decreases. And the neutral is nothing would happen if one increases or decreases. The second one is like that only, right? So that is what correlation is all about. But when we talk about regression, it talks about the same thing, but what it is going to do is it takes the Pearson's correlation value, correlation coefficient, squares it up, and tells us what is the possibility of relationship between these two things. But it is important when we are doing regression tests, we create a regression equation to predict the value of something based on the value of other variable that we are already having. So that is what regression test and regression equation is all about. This is used for predictive analysis. It says that if at all I have 20 people who like Cadbury chocolate, then how many people would not like Cadbury chocolate? Based on my regression equation, I can find out. If there is an equation, right? If there is an equation that talks about multiple regression equation, if that talks about male, females liking, disliking Cadbury, then if I have 5 males and 6 females liking Cadbury, then how many of them would not liking this chocolate? I can predict that. So that's how predictive analysis works, and regression test talks about those things. Keep in mind, if you're trying to do regression or predictive tests, predictive things in your research, then you have to do the regression analysis. The second thing is about comparisons. You are wanting to compare the data. You are wanting to compare the variables, right? The tests include t-tests, tests where you are comparing two variables, right? I might be having control, which did not get any drug. I might be having, I want to see the happiness index of my students or my participants in this classroom. One group gets Cadbury chocolate, the other group does not get Cadbury chocolate. I give them something. I say that, I am giving you something, but this chocolate is sweetless chocolate. It is a Cadbury chocolate wrapped in Cadbury wrapper, but it looks like Cadbury chocolate. But when you eat it, it's bland, sugarless, bland, right? Whereas they are getting the sugar. Now, happiness index, I want to find out. This group which got the bland, I call it as control. And this group which got the sweet Cadbury chocolate, real Cadbury chocolate, this is a treatment. In the next group, I'm giving something else in the Cadbury wrapper, right? Right? And then I want to test that. So, but if I am having only two groups, I would be doing t-test. This is the control, this is the treatment. That's how it works out. If I bring in the third one, I get into the domain of analysis of variance. I'll come to that later. Then the paired t-test talks about, equivalence, equal number of people, equal number of subjects. Also, it talks about like, I take the happiness index before giving you Cadbury chocolate and after giving you Cadbury chocolate. I want to understand how much you know about statistics before I enter the classroom, and after 1.5 hours, I will give you one questionnaire and find out how much you know about statistics. So that's about the pair. The same person getting it. We have already done these kind of things, like कभी आप blood test को जाते हैं तो होता है ना, right? Postprandial बोलते हैं and fasting. So they compare it, right? ऐसे आप 10 बार कीजिएगा, आपको मीन आ जाएगा. 1000 लोगों का मीन लेकर health researchers are talking about all these things. अपना data ले लेते हैं, but they are doing research over there, right? That's the paired t-test. Then you have independent t-test. It is also two sample t-test. Like, you have a sample here, you have a sample there. You don't have the same kind of, numbers and all such kind of things. So that's an independent t-test. And we are trying to find out whether or not the means are statistically significant or not. And then we also have one sample t-test in which you are trying to find out the mean of this population, whether this population mean is kind of, reflecting already reported mean. For example, if somebody has said that, in a particular population, maybe a tribal group, maybe Chanchus, this was the mean height in 1957. Now, somebody goes over there and tries to do the height analysis and of the new population now in 2022, 23, they bring the data. Now, the biggest question is, the sample that I have taken out, does it represent the original population or not? Right? There is a comparison. There is only, you have the mean and standard deviation from the original test, and you would be doing mean and sample deviation from the same population you're doing to find out whether the sample belongs to the population or not. So that is what one sample t-test is all about. Huh? No, that will show that is it because of chance or is it because of bias. I asked my research scholar to go and to get the Chenchu heights, and he went and got Lambada heights. Yes, then you say that in biologically in the course of time they have Chenchus have either become taller or shorter, right? So that's how you have to interpret, right? Then we get into the comparison test that talks about multiple variables, and that's all about analysis of variance. Analysis of variance could be a simple analysis of variance, like I have 3 groups or 4 groups. In this class I have 4 groups, 1, 2, 3, 4, and I want to find out the mean age difference in these 4 groups. So I will do one-way analysis of variance, right? I will try to find out if the means are different, right? On all these things, I have not talked about null hypothesis and alternate hypothesis, which is the statistical hypothesis. I will tell you now after some time. But when we are thinking about, in my class, I have both the genders, right? In that group, I have both the genders. In this group, I have both the genders here. I have both the genders here. Also, I have both the genders. Now, I want to find out, is there a difference among the genders in the group also? So what am I doing? I'm bringing grouping, right? Age I'll bring in, or I'll bring in the understanding by the perspective of science, social sciences, and humanities, etc., all those things in different groups. So I can make many different groups and look at the subgroup or group variations also. These are groups and genders are subgroups. So that would be my two-way analysis of variance. Most of the time my students are doing this kind of study, but they don't know how to apply the two-way analysis of variance. Most of the time you are going and getting the data from both males and females. But when you are reporting, you are doing one-way analysis of variance and showing me the difference. You have left very, very major part of the analysis that tells also there might be some kind of variation. Then when we have such kind of variations, how am I going to find out whether the females of this group and the females of this groups are really different or not? Males might be different, females are different or not. Then I do something called as post hoc t-test. Again, the test would compare only two groups, group A, group B, group A, group C, group A, group D, right? So that's how you plan up your study, because if you don't do all these things, it becomes difficult for either you or anybody else. The screening committee going through your proposal, they might be like, okay, if you don't know how to do the statistical analysis, kya karoge yaar, is the biggest question, right? So then we have multiple and multivariate analysis of variance, that is also called as MANOVA, wherein we are bringing in more type of variables and all those things. Then we have z-test. Z-test is just like your t-test, but it is applied for a large sample size. N should be greater than 30. N should be greater than 30. In social sciences, you can do the z-test, but not the t-test. So correlation, as I told you, talks about the relationship between the two variables that you are taking into consideration. It could be more than two variables, but you have to remember one should be dependent and independent, right? So then when you are talking about more dependent variables would come into picture. Then non-parametrical, then we have chi-square test, where we are having two category variables and we are looking at chi-square test also becomes complex, but basically it talks about, how your observed frequency is matching the expected frequency or not, right? So wherever you have ratios that talks about, then you can apply the chi-square test, and you have to remember this is a non-parametrical test. It's almost done now. It's almost done. So we are into the kind of, final step wherein we have to start thinking about how am I going to choose what statistical test is right for me. First question, you have to ask that research question. Research hypothesis, is different, research question is different. Your objective becomes the research question, right? This is my research question, and then you start formulating the hypothesis, statistical hypothesis, not the research hypothesis. This is where you have to ask, what am I asking? Most of the statistical analysis, when we are doing, the null hypothesis states that there is no difference between the means of the groups that you are testing. It could be one group, two groups, three groups, multiple groups. There is no difference. And we have alternate hypothesis that tells us that there is at least one difference. One group is different. One of the means is different. Now you start with that control and treatment. Null hypothesis says that there is no difference. Alternate hypothesis says that there is a difference. Then statistically what you have to do is you are reject, you have, when you find out there is a statistically significant difference, then you reject the null hypothesis. That says that there is no difference. I'm rejecting the null hypothesis because compared to when the real chocolate was given to the treatment group, they were more happier. People were not happier. That is what I have to prove, right? Null hypothesis says that no effect, right? No difference between the happiness index in both the groups. So you have to start formulate the null hypothesis and get into setting up the level of significance by thumb rule. When I was saying level of significance, by thumb rule, P should be less than 0.05. And as soon as you do the analysis and you see the P value is less than 0.05, you are rejecting the null hypothesis. So that proves that there is some kind of statistically significant difference between the means of both the groups, right? And then you start thinking about whether your test should be one-tailed or two-tailed. Usually when I say that if you are getting confused with how many tails I am having, say two-tailed. You start with two-tailed. Just don't worry about that, one-tail thing. You start with two-tail and say that your analysis is based on two-tail analysis, and you do that, right? And then number of variables. How many variables are there? What type of variables are there? Based on that, you choose the test, right? As I told you, if you have only one, then you do the t-test, or if n is greater than 30, you do the z-test, right? If you have just two variables, do the t-test. Who asked you to get into the ANOVA? Because sir, mujhe ANOVA aata hai, main ANOVA karunga. No, you do t-test, right? If you have multiple variables, do the ANOVA rather than sir, मेरे को टी टेस्ट अच्छी तरह से आता है उसमें 10 बार टी टेस्ट करूंगा, right? So all those things you have to be careful with, and then see that basing on number of variables that you are having, you would be doing the that is one important step. And then basing on the type of data, we have seen that if it is continuous data, where you have to go. If it is discrete and categorical data, you get into the non-parametric domain, right? And from there you go into chi-square, Kruskal values, and all such kind of tests. And finally, you are looking at whether you have paired or unpaired studies designs. Whether you are pairing the study designs or unpairing, you don't have such kind of pair and all such kind of things. Depending upon that, you would be deciding about the type of statistical analysis you would be doing, right? So basically, what you have to remember is paired designs include comparisons, right? If you are talking about paired designs like the blood pressure or the blood sugar value and all such kind of things before fasting and after having your lunch and all such, or after having your meal and all such kind of things. So that is the paired designs and all. So you have to keep in mind that, like in social sciences also, what we can think is about, yes, I give you a training. What was your understanding about that particular thing? We say that yoga is good for health and all such kind of things. Put up a questionnaire test for people who were not doing anything about yoga. Find out about their comfort levels, how happy they are, how meticulous they are, and all such kind of things. And then take them through yoga workshop for 1 month. And after that, you put one more questionnaire to find out what type of happiness they are feeling and all such kind of things. Same questionnaire would be there, but as a researcher, you would not be giving the Xerox copy. You would be making little changes in the question that but your answers are same. You will be getting main ye question pucha tha uske liye. Now that after 1 month of training or yoga camp. Now the same question I'm asking, but in a different tone, right? And I will get an answer which talks about, then I compare, right? So those are about the pair design things. So again, pair design from science point of view, again, you can think about, set of patients before treatment, after treatment, right? You can do a set of patients who are not given treatment and who are given treatment, control and this. But pair design talks about before treatment and after treatment, right? So I would like to take the WBC count before treatment, and after I have given the antibiotics, I'm trying to see the WBC count and all such kind of things, whether there's a difference or not. So basically, this is what you have to remember, that you need to think very carefully through this. When you are writing your research proposal, synopsis, you need to mention, if you do not know about the intricacies of all the tools that you have so far seen, at least if you mention that I would propose to do statistical test or t-test, because I am working on two variables, this variable and this variable. For each, when I said that each objective needs to have methodology, separate methodology, at the bottom you write that the data would be presented in the form of mean plus minus standard deviation if it is quantitative data. If it is qualitative data, you would say that it would be presented as median and range, right? And then later you say that because I am working on two categorical or continuous data variables, I would be doing t-test. I propose to do ANOVA. I propose to do chi-square test. That would put your synopsis a notch higher than all the other synopses that would not be having this data. Because you need to understand that means that you have clear-cut idea about what research methodology is all about, what research process is all about. You are having understanding of the 8 steps involved in research methodology, and you have an understanding, clear-cut understanding about the crucial 7th step that is needed for making any inference of your research that would be the soul of your research paper or research thesis. But to give you a kind of warning, you should be in consultation with your principal investigator or your guide or a statistician if you have not learned all those things. But I tell you that if a person who got just 47 marks in 10th class mathematics is teaching statistics and doing statistics, anybody can do it. Thank you very much. This is the session is open for some of you are wanting to catch trains, buses, trains, and all those things. You can leave for another 5-10 minutes. The session is open for questions. Yeah, please. Yeah. Forget about it. If it is not useful, forget about it. No. I'm also very open. I'm also very open. If it is not applicable to your research, forget about it. Simple. I always say that if I don't want to go to that one today, I will not even go to the workshop and ask for my why? Right? I'm not interested. My target is not going to that today. So why would I ask you what the work I'm wasting my time. Forget about it. Statistical analysis is not going to be the component of your research as our framework mentioned. There are mistakes and anomalies. It is not. No, you cannot. Sometimes you cannot force certain things into domains that do not use this.